Hi, everybody, and welcome to our final part in our macromolecules lecture. And what we're going to be focusing on today is specifically lipids, so one of our last pieces. And what we're going to try to accomplish today is two things. The first is we want to see exactly what the role is going to be of these lipids. So what are they going to do and how are they going to influence our everyday lives? What do they do in order to help us survive? And what do they do to help us live our lives as normal? Then we're also going to classify the different types of lipids. We're going to have three different types, and we're going to see exactly what their functions are going to be, what's so special about them, and how do they contribute to our daily lives. So before we do that, we need to go ahead and understand exactly lipids and what they are in our human body. So there are going to be three different types that we're going to be focusing on. Those are going to be our triglycerides, our phospholipids, and then our steroids. So triglyceride, just like the name suggests, there's going to be three pieces, or in this case, three tails connected to a glycerol. Phospholipids are going to be kind of barriers. We're going to have hydrophobic and hydrophilic ends, which are going to dictate what comes in to our cell and kind of what leaves the cell. And then finally, steroids, which are going to be things or hormones like testosterone, estrogen that are going to kind of help us dictate what's going on with our body. Now, one thing that's kind of important though is lipids are hydrophobic generally, which means that they do not normally mix with water. A great example of this is if you go ahead and take oil and you try to mix it with water, you know that they don't necessarily mix. We'll have water here and we'll have splotches of oil over here because again, they are not going to mix together. So that's kind of what lipids are. They are hydrophobic, hydro meaning water, phobic, meaning fear, so they're fearing water or do not like to interact with water. So let's go ahead and check out the lipid types and their functions. Now, these are going to be the three different types we have. We have them over here, and we also have the function as well. One thing I would definitely do is put a star here, underline, do whatever you need to do to kind of make this slide stand out, because this is going to be a great way to see exactly the different types of lipids we have and then exactly what they're doing. So let's go ahead and break this down. When it comes to triglycerides, there's going to be a couple of things that they do. The first thing is they are going to be great at energy storage. Our body likes to store energy or excess energy away for later use in case we come into a time of disparity where we don't have access to lots of energy, so our body can use those fat storages. They're also going to provide protection and insulation of our internal organs. So again, help protect, give us some buffer zones, things like that, as well as keep them warm and maintain body heat. Triglycerides are going to be the main lipids that we are going to be storing, and they are going to be stored in something known as adipose tissue, or in this case, they're going to be stored as fat tissues. Our second type is going to be our phospholipid. So our phospholipid is going to be a very unique type of lipid. And the reason why is because it's going to be found outside of the cell, or in this case, our cell wall. And what it's going to do is it's going to dictate or let us know what's going to go out and what's coming in. The reason why is because we have something known as a selectively permeable membrane, meaning that only specific things are allowed in and outside of the cell. Finally, steroids. They're going to be most commonly known steroids in the body in cholesterol. Cholesterol is going to make up bile along with vitamin D and hormones. And those hormones that we're going to be specifically talking about are going to be progesterone and testosterone. So you can see that we have one, two, three types of lipids, and they all have their own unique functions. So let's go ahead and check out triglycerides first. So when it comes to triglycerides, this right here is going to be an example within adipose tissue. And again, triglycerides are stored inside of this. So you can see that we have our lipid droplet here, which is going to be a triglyceride. You can see that all of this is going to be the cell all around here. And all of this is considered our triglyceride, or in this case, our adipose tissue or fat. Okay. And the reason why we call these a triglyceride is because, just like the name suggests, just like a tricycle, you have three parts. And then our glyceride, we have our glycerol right here, just like our name suggests here, connected to three tails, tri, 1, 2, 3, which are going to be chains of fatty acid. So this is what that's going to look like chemically. You can see that we have our glycerol here, and then we have our fatty acid tails coming off to the side here, here, and here. Our next type is going to be our phospholipids. So our phospholipid can be found right all around here in our cell membrane. And what our cell membrane is it can be found in plant and animal cells. But in this case, our cell membrane, looking at human cheek cells, animal cells, are going to allow things to come in and out. They're going to be selectively permeable, meaning that, again, they're going to be able to let certain things in and out, again, maintaining and containing the integrity of our cell. Now, when it comes to our phospholipid, one thing that's really important is we have some of these phospholipids making up that cell wall. Now, what we have is a hydrophilic head. Okay, hydro, again meaning water, H2O. Philic meaning loving. So in this case, the head enjoys water, likes water. Then we also have a hydrophobic tail. So hydro, water, phobic, fear, meaning they do not like water. So we have two kind of opposite ends. And this kind of presents us with a very unique characteristic, because what will end up happening is we can end up with our cell membrane here, where we have something known as a phospholipid bilayer. Bilayer, bi, two, just like a bicycle. You can see we have one layer here, and then we have our second layer here. You can see that our hydrophilic tails are going to be attracted together, and then our hydrophobic tails are going to be attracted to each other, and then our hydrophilic ends are going to be off to the side. So you can see that when they're coming together, there is going to be an absence of water here, and then the hydrophilic areas are going to be exposed or extracellular, exposed to the outside, and then the other end is going to be intracellular, exposed to the inside. So this creates that unique layer, our phospholipid bilayer, in our cell membrane. And again, remember, our cell membrane is going to protect our cell by dictating what's coming in and what's coming out. It's going to also help maintain the shape and things like that. Okay, and then our last one is going to be our steroids. So when it comes to steroids, cholesterol is going to be the most common type of steroids. They can be synthesized within the liver, and then they are going to be precursors to vitamin D, bile salts, and again, they're going to be important components in cell membranes. Again, they're also going to be precursors to progesterone and testosterone. So again, steroids are going to be important for these reasons. And then over here are some examples. You can see we have our cholesterol, and then you can see they are precursors for those different items, which are testosterone, estrogen, and cortisol. All right, and that is going to conclude our lecture on fats or lipids. Again, we have those three different types. We have our triglycerides, phospholipids, and then we also have those steroids. So just like all the other lectures, what I'm going to do now is I'm going to give everybody a couple seconds to pause this, give these a try, and then we'll go ahead and check these out together as a class. All right, welcome back. And these should be the answers. So in this case, we're going to look at number one, which of the following is true in regards to triglycerides. So remember, tri-3 glyceride, we have them all connected by glycerol. So in this case, it should have been C and D. The cholesterol is not a precursor for which of the following molecules? Remember, phospholipid and triglycerides are going to be different types of lipids. So these would not be, but they are precursors for vitamin D, bile salts, as well as testosterone. Number three, what features of phospholipid allow for the cell membrane? In this case, phospholipid, remember this, is going to have a hydrophilic and then a hydrophobic tail. Remember, we're going to create that lipid bilayer. So we have one layer here, one layer here. We have the absence of water in the middle, and then we have our extra or out cellular and then intracellular. So in this case, we have a hydrophilic glycerol head and we have a hydrophobic fatty acid tail. So remember, the head right here is going to be hydrophilic. Remember, hydro, H2O, meaning water, philic, meaning love. So they do like water. And then our tails, hydrophobic, remember H2O, hydro, and then phobic, fear, meaning they do not like water. All right, and that concludes our lecture. So if anybody have any questions, comments, or concerns, please feel free to reach out. Remember, the best way to reach me is going to be either email or on Canvas. Look forward to seeing everybody in the next week's lecture.